So what might be a more interesting coordinate space to look at than what we've previously seen in 2 dimensions with the Cartesian coordinate plane are graphs in 3 dimensions and 3-dimensional coordinate space. So typically when we're graphing in 2 dimensions, we have what's called ordered pairs. And you've seen ordered pairs in the past, and they're typically of the form some quantity x comma some quantity y. But now we're going to add an extra axis, and this is the z-axis. So now what we're actually going to be graphing are ordered triples. Ordered triples. And these are of the form x, y, and then of course z. So this is possibly more interesting because this is actually the space that we visualize the world around us. So when you look at the corner of the room that you might be maybe sitting in, you may see 2 walls meeting each other with a floor. And this could be represented using the x, y, and z axis, or axes rather. So if we're given a plane, and a plane is an object that lives in 3-dimensional space. It's a plane could be represented by the top of the desk you're sitting at, if it continued on into infinity in all directions, or just the top of the desk, just the very, very, very top sheet layer of your desk could be considered a plane. And so the equation of a plane typically looks something like this. So say we're given a plane that is of the form x plus 2y minus z equals 6. Okay, so this would be an example of a plane in the 3-dimensional coordinate space, and that is represented right here. So these are the same x and y axes as we've seen previously in 2 dimensions, but now they're kind of laid on their side, and we have this new z-axis running up and down. So the way that we're going to graph this equation is we're going to do a couple things. First, we're going to take x and let it be 0. We're going to allow x to equal 0. So if we do that, we have 0 plus 2y minus z equals 6. And then we're given, if we solve for y here, we can have an equation, y equals some value in terms of z. So if we add z to both sides and divide by 2, we're going to have y equals z over 2 plus 3. Okay? Then what we can do from here is we can actually look at the yz plane. So the yz plane is the plane that is represented by the y-axis and the z-axis, and you've seen planes previously in geometry. And what we can do is we can imagine this y-axis and this z-axis, but if we're explaining y in terms of z, so z is our independent variable, then that means we're going to have to imagine the y-axis and tilt it to the left 90 degrees. And then we're going to have a y-axis and a z-axis that we can actually start graphing in. So if we imagine that we've tilted the yz plane, and now we're looking at the y-axis standing upright and the z-axis pointing to the right positively, we can start actually graphing this. So our y-intercept is 3. So if I were to make some points or some tick marks here, we would have a point at 3. And then our slope is 1/2. So if I go down 1 and to the left 2, or up 1 and to the right 2, I should have 2 points that I can make a line with. So let's do that now. So I have a point here at y equals 3, and then I'm going to have a point on the z-axis. If I go from this point here down to the z-axis at -6. And I'll explain in a moment why it's -6. So 1, 2, 3, 4, 5, 6. And then we can make a point. So here I am representing this y-axis positively by pointing it upwards. I'm thinking about this y-axis pointing upwards, and then the positive part of the z-axis pointing rightwards. So what we're doing is actually flipping this whole plane around n on its side, and determining what these intercepts would be if the line was essentially graphed in the xy axis, or the two-dimensional coordinate space. So what I'm going to do is I'm going to connect these with a line. And then we're going to move on to our next linear equation. So we've imagined x at 0. Let's do y now. So if I change colors, we have x plus 2 times 0 minus z equals 6. Okay, so this is leaving us with x minus z equals 6. So now we're going to have to look at the xz plane. So the positive direction of this x-axis is in this direction right here, coming towards us. That is the positive portion of it. So we want that to point upwards, and the z portion, the positive z portion, to point rightwards. So if we can flip this around in our heads and imagine that, that is the space that we want to be imagining. So if I were to do that, I can go back down to this. I have x equals z plus 6. Okay, so in that case, I have a x-intercept of 6. So I'm going to make some tick marks on the positive x-axis. 1, 2, 3, 4, 5, 6, and make a point. And then I'm going to imagine the z-intercept for this. Now, previously, what we did to figure out the z-intercept in the yz plane is we just solved for z, and then we had z equals 2y minus 6, and then minus 6 was our intercept. So this is actually at -6. And this is at +6. And this is at +3. Okay? So if we were to look at this equation again, and then we were to solve it in terms of z, we could figure out the z-intercept. And the z-intercept is -6. So it also actually crosses through this point right here at -6. And I can draw that by connecting a line through these 2 points, like so. Okay? All right, and then the last one that we haven't done yet is what if we made z equal to 0? And if we made z equal to 0, this is what we would be left with. We would have x plus 2y minus 0 equals 6, and then we're left with x plus 2y equals 6, or x equals -2y plus 6, or if we were to bring this 6 over and this 2y over, actually we could just bring the x over to the right-hand side and then divide by 2. So then we're left with y equals x over 2 plus 3. All right, so now that we have this linear equation, our last one and this is in our typical xy plane. Excuse me. So our y-intercept for this is going to be 3. So let's imagine this xy plane. Now all you have to do for this is actually just look at this kind of sideways plane right here and imagine that you're looking down on it. So our y-intercept is going to be positive 3, which is this point here. And then our x-intercept is going to be positive 6. And here it is, this point again. So you may be seeing a pattern here. And if I draw that line, it has another linear equation in 3 dimensions. So if we were to take this area and start shading it in, so I'm going to take this area, I'm going to shade the inside portion of it. And now, bounded by these 3 lines is what we can actually represent this plane as. So the equation of this plane actually looks like this in 3 dimensions. And now that we've found the intercepts for the x, y, and z axis, we can actually represent that just using the 3 linear equations that we had.